Hello everyone. So today we'll go over the topic of inventory management. That's your chapter 12. And paying attention to this chapter, especially at the beginning where we are starting with basic and simple formulas, is very important. And the main reason is as much as we move forward, there will be more complex formulas and procedures that they are actually based on, or they are dependent on these basic formulas we learn at the beginning. So if you learn these basic formulas at the beginning, you most probably won't have any problem understanding the rest of the topics. But if you don't understand these first steps, then you will fall in trouble when you want to learn the next steps, okay? So please pay attention, have a note, have a paper and a pencil, take note, and perform calculations that we go over to make sure that you have understood and you have learned the topics. So outline of chapter 12, our global company profile. It's amazing. It's Amazon. So you know that Amazon is one of the companies that has one of the largest inventories in all over the world. And they actually have the management they have behind this inventory management is really highly complex calculations, programmings, operations research is involved, a lot of mathematical modeling is involved, a lot of statistical and data analysis is involved here, okay? We will talk about the importance of inventory, managing inventory. We will talk about few types of inventory models with independent demand, and inventory models that are dependent, and probabilistic models and safety stock. And we'll talk about single period model and fixed period systems. So I want you to make sure you go and read the information provided on Amazon.com. and also watch the video that is provided to you on my lab. So you understand that the inventory in Amazon, at the time that this book was written, maybe it was not as advanced as today, but there is still a lot of information that you can learn from. Our learning objectives are, you will learn how to conduct an ABC analysis. You will learn how to explain and use cycle counting, explain and use EOQ model for independent inventory demand, compute a reorder point, and explain safety stock. You will learn how to apply the production order quantity model, how to explain and use the quantity discount model. You will also understand service levels and probabilistic inventory models. What is inventory management and what's its objective? So the objective of inventory management is to strike a balance between inventory investment and customer service. So this is always big issue here, right? The issue is that it's costly to keep items and to keep stock in your inventory. It's costly. And because of that high level of cost, you don't want to spend a lot on inventory. You want to keep enough inventory for your daily usage or weekly usage. And you want to make sure that there will be a logical, statistical process of ordering items. And when items get into your inventory, with lowest cost possible, we can deliver them to our customers. And at the same time, we don't want to get out of stock. We don't want to have empty stock, because when the customer comes in, we want to make sure we have items to sell, right? We don't want to lose the customer because of empty stock, so or lack of stock. So there should be a balance between the cost of having inventory and keeping your customer satisfied by having enough inventory, enough stock in your inventory. So one of the most expensive assets of many companies, representing as much as 50% of the total invested capital, is in their inventory. Less inventory lowers the cost, but increases the chances of running out. And when you run out of stock, then there's another cost, which is when you lose your customer. That's a cost associated to it. More inventory raises your cost, but always keep customers happy. So as a result, we want to keep a balance between having more inventory and versus having happy customers. Functions of inventory. So to provide a selection of goods for anticipated demand and to separate the firm from fluctuations in demand, inventory actually can help us, right? To decouple or separate various parts of production process, and also to take advantage of quantity discounts, and also to hedge against inflation. So when you buy a stock in advance and early, if the price of that stock, the price of that item goes up, you won't have any problem, right? Because you already have bought and you already have it in stock. So we have different types of inventory. Raw material can be considered inventory. It's purchased, but it's not processed. So we keep it in the inventory to use it or to combine it with other stuff, right? Work in process. So when a raw material goes into the factory and it's in process of creating a new production, right? That assembly line is using that raw material. That item is in the work in process or work in progress. Undergone some change but not completed. A function of cycle time for a product can be calculated. Maintenance, repair, operating, or MRO. It's necessary to keep machinery and processes productive. So inventory can be, when you have raw material, it can be considered as inventory. When they are in working process, they can be considered as inventory. When they are into maintenance, repair, operating, each of these cases happens, they're considered as inventory. And when you produce, your product is completed and produced, you need space to keep them so that later you can sell them, right? So that's also considered as inventory. Completed product awaits shipment. So let's consider this as the material flow cycle, and you can see that the inputs or raw material comes in, they are being weighted in a certain area. So that's cost, that's waiting for these is costly, right? They have to wait for inspection, they have to wait to be moved, and then you will move them, transport them to a new place, wait in the queue to be processed. There is a setup time, and there's a run time, and at the end of the process, you have your product ready. So that whole process from the beginning that input comes in until the product is out, that's your cycle time. So on managing inventory, how inventory items can be classified. So there are different and actually more complex methods here, but we are introducing you one of the basic models in classifying inventory. So the analysis you will learn here is called ABC analysis. And the question is how accurate inventory records can be maintained. ABC analysis divides inventory into three classes based on annual dollar volume. The class A are material or items that are high annual dollar volume. They are more expensive, they are more valuable, but they can be small. They might just be like 20%, 15% of your overall items, but they have a high value. So we put them on class A. These are valuable stuff, right? So they're important to us. So when we are doing records, we need to spend more time and more investment on these class A items. Class B are medium annual dollar volume, and class C are low annual dollar volume. So low annual dollar volume are the cheapest material that normally we have thousands of them, millions of them, and their value is very low. So we can have less control over them. So those items that are highly valued, we want to have more control over them, more regular recordings. On those that are less valued, we want to have less, we want to spend less time and dollars to control them. Use to establish policies that focus on the few critical parts and not the many trivial ones. So this is an example of ABC analysis. You can see 15%, a small portion of your items in inventory might have high value, maybe 80% of the value of your whole 1 year annual dollar usage. And we have C items where they are more than 50% of your items, but their value is even less than 10%, even close to 5%. So they include like more than 50 or 60% of your items, but they have a very low 5% value. But A items are the ones that they have a low portion of your items, but actually they have a highest value, normally 80 or 90% of your values. So this is another example of ABC analysis. And what we can see here, the 20% of our items, there are just 2 items. And these 2 items, we have 1,000 units of one and 500 units of the other. But you can see the values are high, $90 per unit, $154 per unit. Total value of these items are $90,000 and $77,000, together $167,000. And percent of annual dollar, in dollar value, they include 72% of all of our stock, all of our items in dollar value. However, in number of values, number of items, they're 20% of our items. That's why we put them in level A. And that's this is a tag on it to say that we have to do more control, take more care of these stock, maybe more regularly record them and see how many of them we have left. And when ordering, making sure that we order them more regularly, and then we make sure they are in a safe area and we have a good record of it. And you can see opposite of class A, we have class C, where we have more items. Total number of items is 8,550 items, right? Looking at the prices, they're very low priced, $14, 60 cents, $8.5, 0.42 cents, right? 42 cents, 60 cents. So low value. And when you multiply it by number of them, the values are all below 10,000, right? Percentage total, all of them together, In value, they're just 5% of your total items value. All of your items value, these are just 5% of it. So, and we have a lot of it, right? 8,000 items. So this is telling us we put them in group C. And in group C, we know that we can have less control over them because they're cheaper material, cheaper items. Those in the middle, somewhere between 10,000 to 20,000, we put them maybe 10 to 15,000 or 30,000. We can put them in group B. There is no specific guideline on this. It really depends on the type of items we have and the prices we have. And we can divide them into, and it's easy to recognize. You always can recognize expensive items versus cheaper items. You can look at the prices. When you multiply by number of them that we have, you can see that the total amount here is less than 10,000. Most of them are like even less than $1,000. But here we have somewhere between 10 to 30,000. And those two items, they include over $160,000 of value. So it's obvious that we can separate them into different groups. Other criteria than annual dollar volume may be used. You can also use high shortage or holding cost. So if the holding cost is high, we also need to take care of them in a different way. Unexpected engineering changes, delivery problems, quality problems. We won't go over these, but these are different options that we have. Policies employed may include, so more emphasis on supplier development for A items, tighter physical inventory control for A items, and more care in forecasting A items. That means if you want to use 90% or 99% confidence level for items in category B or C, for A, you want to use 99% of confidence level in your decision making. Record accuracy. So accurate records are a critical ingredient in production and inventory systems. Periodic systems require regular checks of inventory. So perpetual inventory tracks receipts and subtractions on continuing basis. Incoming and outgoing record keeping must be accurate. Stock rooms should be secure. Necessary to make precise decisions about ordering, scheduling, and shipping. So one of the softwares that is taking over almost for every company all over the world is SAP. So the software actually helps you to integrate your whole system from raw material. The whole supply chain is under cover from delivery. Items are all tagged when they can all be tracked where they are in the shipment. When they are delivered, the payments can be tracked. Everything can be tracked. So when the item is sold, immediately in the system is recorded. So it's an automated system. And I highly suggest you to learn SAP software because you can easily get a good job with more than 90 or 100K annually.
Is there a class for that?
Pardon me?
Is there a class for SAP or just...
I'm not sure at Sac State we have, but I know Chico State, they provide actually a program. They have a class that they will teach you the whole software.
Okay, cool. Thank you.
Yeah, I mean, Chico State, they actually have, they are the branch of Northern California for educating people in the Northern California on SAP, and they provide services. So they're really good at it. And I think you can get a course online with them, and they will provide you with real data. So there are real data available for the course provided. You just need to get the software. They will provide the software for free to the students. And it's actually a very good course, but I'm not sure about Psychostate. I will ask and let you know if we have it too. Thanks for asking. Items are counted and records updated on a periodic basis, often used with analysis, and has several advantages: eliminates shutdowns and interruptions, eliminates annual inventory adjustments, trained personnel audit inventory accuracy, allows causes of errors to be identified and corrected. Again, in maybe old days or less advanced organizations, companies, you have these done manually, but in most advanced companies that they use technology, all these are actually automated and are being done by machines and computers. So this is an example. We have 5,000 items in inventory, 500 A items. We have 1,750 items group B or category B, and 2,750 category C. Policy is to count A items every month with a 20 working days monthly. So B items every quarter, every 60 days. And C items are counted every 120 days. So that's showing when items are in a higher level of class A, we have more control. We have more counting on them. When the value goes down, we have less counting, right? Control of service inventory. So can be a critical component of profitability when you have a good control over your inventories. Losses may come from shrinkage or pilferage, right? And applicable techniques include good personnel selection, training, and discipline, tight control of incoming shipments, effective control of all goods leaving the facility. So we need to make sure there's a good control over our inventory. So taking control of your inventory can actually avoid losses. So what type of inventory models do we have? We have two types of inventory models that we discuss here. Independent demand. The demand for item is independent of demand of any other item in the inventory. So they are not associated, right? Or we have dependent demand, where the demand for item is dependent upon the demand for some other item in the inventory. So we will go over these and you will see how it works. So you can start taking notes because we are actually starting to move into the formula part, right? So what is a holding cost? Holding cost is the cost of holding or carrying inventory over time. So you don't want to hold on to an item for a long time because that is costly to you. You want to make sure an item comes in, and in a few days, sometimes if the inventory is very tight, you want to make sure that in a few hours, the item is sold or processed. Then we have ordering cost. So that's the cost of placing an order and receiving goods. So ordering normally happens when you're going to go out of stock, right? When your inventory, you sell your inventory or use your inventory and your inventory start going down. Before you're out of inventory, before your stock has finished in your inventory, you want to place your order, and that is costly. So there is an ordering cost involved in our calculations. And then we have setup cost. That would be the cost to prepare a machine or process for manufacturing an order. And studies have shown that there is a high correlation between setup time and setup cost. Some examples of holding costs: building rent or depreciation, material, equipment lease or depreciation again, labor cost, receiving, warehousing, security, investment costs, borrowing costs, taxes, insurance, and also pilferage, space, right? So much higher in industries undergoing rapid change like tablets or smartphones. Holding costs vary considerably depending on the business, location, and interest rates, generally greater than 15%. Some high-tech and fashion items have holding costs greater than 40%. So looking at these numbers does not necessarily make it a rule that we have 6% or 3% on similar examples out there. It's actually really depend on the business and topic we're talking about. The percentages can be different. So inventory models for independent demand need to determine when and how much to order. So we're going to use EOQ a lot. So remember, EOQ stands for economic order quantity. Economic order quantity, or EOQ. So we will learn basic economic order quantity, or EOQ model. We will learn production order quantity model, and also we'll learn quantity discount model. So there are important assumptions about what you will learn in EOQ model. These assumptions are mainly because the way that we do calculations, we are actually ignoring many factors. We're just spending and considering some certain factors, and normally consider those factors to be linear. As a result, we want to make simple calculations rather than complex calculations. Is it possible to have higher level of accuracy in more complex formulas? Yes, there are more complex formulas being used out there, but for this course, at this level, this is the way the course is designed, to have some simple formulas. Important assumptions are: we are considering that demand is known, demand is constant, and it's independent. So nothing actually affects demand. We are considering the lead time is known and constant. And lead time, what we mean is the time that we know we're going to go out of stock and we decide to put order, right? The time that you put order until the items are delivered into your inventory, that is your lead time. So you need to make sure you know when a certain amount of items are left in your inventory. You need to know when to put your order so that when you're out of stock, the new items are delivered to your inventory. Receipt of inventory is instantaneous and complete. Quantity discounts are not possible at this point. Only variable costs are setup or ordering and holding costs. Of course, there are other costs involved, but we are not considering them in our calculations. Stack outs can be completely avoided. That means we're not working based on probabilities here. We're considering, we already know how many items are going to be sold, how many items are left at a certain time. inventory usage over time. So you can see in this graph that for the model that we are going to explain at this point, we're considering a very simple model, right? The model is your inventory is full at the time of 0, and there is a certain demand. As a result, by time, there is a fixed amount of inventory items being used or sold. And at a certain time, we are going to know that how long it's going to take for us to place order, and we can place our order. Another thing to show here is average inventory on hand would be your highest quantity or order quantity or maximum inventory level plus lowest, which is 0, divided by 2. That's actually the average, right? You take the highest, take the lowest, divide by 2. Highest, lowest, divide by 2. That's Q half. And what is Q? Q is order quantity or maximum inventory level. So we are about to minimize our costs. Holding cost has a function, and you can see that in this example, it's increasing. If you have more items, more quantity, higher quantity, there is a higher holding cost. Setup cost also, or ordering cost also, is a cost that it reduces by order quantity. If you order more items, there will be less cost to it, right? Because probably transportation of more items divides the transportation cost into all of the items you're buying. So more items, higher Q value reduces that setup cost. So you want a balance between these two. You don't want the sum of these two to be very high. So as a result, there will be a point where the summation of these two functions will be lowest. So that red line is the sum of these two costs, which is our total cost, right? So the total cost of holding and setup together creates that red line. The minimum point of that line would be where the holding cost and the setup cost meet. As a result, to find how many orders we need to put as a Q star or optimum order quantity, we need to have the function of holding cost and also have the function of setup cost, make them equal to each other, and solve the equation for Q. Okay, so why are we doing that? Because that minimum point, theoretically, mathematically, we can actually provide you with the proof. The 2 pages of calculation, mathematically, we can calculate and show that this minimum point occurs when we have these two holding costs and setup costs have the same value. Okay, so let's move on. And by minimizing the sum of the setup or ordering and holding costs, total costs are minimized. Optimal order size Q star. So whenever we say Q star, what we mean is this point. That is the minimum cost of order. How many items should we order that minimizes our cost of inventory and setup together, right? That is what we call the Q star. That's what the calculation will give us. So optimal order size or Q star will minimize the total cost. A reduction in either cost reduces the total cost. So that's an important point. Optimal order quantity occurs when holding costs and setup costs are equal. So let's remember these notations. Q stands for number of units per order, how many units you want to order. Q star is the optimized or optimal number of units per order where your total cost is minimized. D is demand, and is normally given as an annual demand, but some problems, some questions, they actually change this to weekly demand or monthly demand. So read the question carefully always, and make sure you know the demand is given per annual or per week or per month. S is your setup or ordering cost. So you have your demand, you have your setup cost or ordering cost, and the last thing you need to know is the holding cost or carrying cost per unit. That's when you have the item in your inventory. When the item arrives in inventory, what's the cost to it? If you're renting a place, what portion of that place is covered by this item? How much electricity are you using, right? All of these are considered as holding costs. How much do you pay for security? How much do you pay for getting the place cold or warm or whatever, right? All of those costs together. So you never need to calculate it. It's always given to you. Holding cost is always given to you. What's the annual setup cost? That's the number of orders placed per year times the setup or order cost per order. Number of orders annually multiplied by setup cost per order. That's a simple one. So what's your number of orders placed in a year? It's annual demand, right? You have to satisfy that annual demand divided by number of units in each order. So that would be demand divided by quantity or number of units in order. So Q is number of units that you buy or you request when you put your orders. You don't have to put order for the whole year. You can put order multiple times in a year to reduce your costs, right? So that Q and demand, they don't have to be equal. They can be different, right? So total demand can be 1,000 items per year, and you might want to order it. It depends on the monthly demand, right? You want to order it 20 or 50 per month or so, right? And that's multiplied by the setup cost or ordering cost, which is S. So your formula for annual setup cost is D over Q times S, D over Q times S. What is that? That's your setup cost, total setup cost. Why are we finding this? Because we want to calculate Q star. So we need the holding cost and we need the setup cost. We need to calculate each one. Question?
Would you please repeat when you get a chance optimal order quantity?
Yeah, sure.
The formula?
Yes. This one?
No, optimal order quantity.
Optimal order quantity. So optimal order quantity is how many items or units to order.
Yeah, you said it was when holding cost is equal to another cost,
Yes.
a setup cost?
Yes, yes.
Okay, thank you.
Where the setup cost and the holding costs are equal. That's the minimum point. That's the Q star is the minimum point we're trying to find. Now, this is your annual setup cost. One of those functions is already here. Now let's find the other one and then find Q based on the formula. So annual setup cost is D over QS. The other one is annual holding cost. So holding cost depends on how many inventory you have. So we get the average inventory level, which is half of the maximum inventory we have. That's what you saw at the beginning. In the model that you saw, it's like a triangle starting from Q, and then we use it, and then we fill up the inventory again, and then we use it. So half of the quantity multiplied by holding cost per unit per year. These values are given to us, so we don't have to be worried about anything. So Q half of holding cost will be our annual holding cost. So now we have two formulas. We have annual setup cost and annual holding cost. To find the optimal number of pieces, or Q star, we need to make these two equal to each other and find Q. That's what we do here. So we make these two functions equal to each other, and the goal is to find Q. So a little basic algebra here, multiply both sides by Q, so that that denominator of Q is canceled. Multiply both sides by Q. On the right hand side, you will have Q squared. Q squared half times H. Why? What are we doing? We're trying to isolate Q. To isolate Q, you need to multiply both sides by 2. So the 2 appears on the left and cancels on the right. And we want to get rid of the H as well. So we divide both sides by H, divide both sides by H. So the Q squared will be equal to 2ds over H. But we are not looking for Q squared, we're looking for Q. As a result, we get a square root from both sides. And only positive values are acceptable because quantity can be only positive. Do you have any questions?
Yeah. Can you explain how they got 2ds equals to Q squared H?
Yeah, sure. Give 1 second to show you. So let me type this in a Word file, okay? D over Q times S equals to Q half times H. So let me bring this down here. So you can see this, right? You can see this Word file?
Yeah.
Okay. Now let's have a little zoom here. Okay. So you want to isolate Q. So I make this a red color. You want Q to be isolated. So what do I do is first, what I do is can multiply both sides by Q. What do I have next? I'm going to have D over S equals to, so that Q in the denominator, I'm sorry, that's D times S. D times S is left. But this is D over Q times S, right? Times S. And this is times H. So D times S will be equal to Q square okay. Q square, and then times 1/2, because we have a 1/2 here, times H. Is this good by now? I multiplied both sides by Q, so this Q is canceled. This Q has become Q squared. I want to isolate Q squared, right? So what I do is, I have to continue. I multiply both sides by 2. Y by 2 because I want to get rid of that 1/2. And I also want, so let's see where this h is. H is actually a multiple. So, and divide both sides by h, right? Divide both sides by h, h will be cancelled. Multiply both sides by 1/2. What should be left is, so result is, so let's put q on the left, so q squared equals, so let's see what else we have. We have 2 times d times s divide by, we divided both sides by h, right? So this 2 ds over h. Let's see. 2 ds over h. Does it make sense?
Yeah.
Okay, nice. Now, but I don't want q squared, I want q, right? So get a square root from both sides. S square root q square root from both sides will give me q star equals to, so I just get the square root of this, right? And so I don't want to use the SQRT of whatever comes out here.
And this gives us the optimal order quantity, right?
Yes, optimal quantity that we should order every time we order, right? So that Q star, in fact, give us this minimum point of the total cost of holding and ordering at the same time. They both are costs, right? But we don't want to have a too much order because the holding cost will go high, and we don't want at the same time, we don't want to have too much items to have a holding cost high, right? So we want to keep things lowest possible. To find that minimum point, we found that formula right here. So Q star equals to 2ds over h. It's very important to understand this formula because when you read the question and you see that demand is given, setup cost is given, holding cost is given, you need to know which formula to use, okay? So this is the very basic formula we have to find Q star. And when you find that Q star, you know that every time you place order, how many items to put in order so that minimizes your total cost. Let's see an example here. So in this example, we have a demand of 1,000 units, setup cost of $10 per order, and a holding cost is $0.50 per unit per year. So the Q star is radical 2ds over h. We just learned how to get the formula, and you will never have to show that work to find the Q star. You just need to know the formula, and you don't need to memorize it. You just need to know which formula to use and just use it. And I recommend you put all these formulas you learned this course on one piece of paper so you can see them and compare them together. There will be a lot of formula coming up soon. So we just plug in the numbers. That's all we have to do. 2 times 1,000 times 10 divided by h, half. That's 40,000 under square root. That's 200 units. That means every time for a problem like this, every time we put order, we just order 200 units. And that will create your lowest total cost.
This is only when demand is constant. You can't predict a
exactly. And we said that at the beginning. We said some assumptions, right? Do you remember we said certain assumptions? One of them was demand is constant. So in the future, we're going to have probabilistic demands where based on historical data, we know what's the probability to have what portion of demand. Then, of course, there will be a different set of formulas coming up. But this is when you know your demand is actually constant. Yes, thank you. So what is the expected number of orders? Expected number of orders is the demand divided by order quantity, or Q star. So if you know that demand for the year is 1,000 units, and you know every time that you place order, you order 200 units, right? How many times in a year should you order? So N is 1,000 divided by 200. That's 5 times in a year to satisfy 1 year demand. So if the question at the beginning asks you to find a Q star, you just use the previous formula. Q star is 200. The next question might ask you, what is the expected number of orders in 1 year? So you just divide demand by Q star. That will tell you how many orders you need to put in 1 year. The next step, what is the expected time between orders? So that would be the number of working days per year. Not every business works every day. Some businesses work 5 days a week. Some work 4 days a week. Some 6, right? So that will be given to you by a question. The question will tell you how many days in 1 year a business is working. Let's say 250 days in 1 year. Divide by 5 times order, because we are ordering 5 times, right? So time in between order will be 50 days between orders. And these days are working days. They're not holidays considered. These 50 days are working days. What else can we do? We can calculate that total cost that we saw in the curve, the minimum point of the curve. That's our total cost. That's the sum of holding and setup costs. So all we have to do is to plug in the numbers. ds over q plus q half h. Plug in 1,000 over 200 times 10, 200 half times 50 cents. That would be $100. Total annual cost. So product cost is not considered in the total cost. If the question gives you the information of the product cost, which is the price multiplied by the demand, if the price of the item is given and the demand, you just multiply them, that will be the product cost. And that's added to the total cost you calculated in the previous slide. So the total annual cost will be setup cost plus holding cost plus product cost if the product cost is given. If it's not given, you just use the previous formula.
Can you go back to that last slide?
All right. So the EOQ model is a robust model. And what that means is, if you change with a certain amount of demand, if you change the quantity of order, there is not much difference in the cost, in the total cost. Okay, so let's see that. Let's assume that the previous question, the values we calculated for the previous question was based on demand of 1,000 units. Now, let's recalculate those numbers for 1,500 units. So what I want from you is go back to the previous problem. Instead of 1,000, use 1,500 demand and find the new Q star. So 200 is the old Q star. Now I'm asking you to find the new Q star based on the new amount of demand. New amount of demand is 1,500, not 1,000 units. 1,500. Use 1,500 and tell me what's the new Q star. Did you find 244?
Yes.
Perfect. So if we have 1,500, demands, the new Q star of 1,500 will be 244.9. Why we're saying here, the EOQ model is robust, right? It's robust because when you have a small change, or even like 20% change, right? 20-30% change in your order amount, there's not a big difference in your total cost. And that is a good thing, right? Because that is telling us that this function is flexible when it comes to your order. Even if you order a little more or less, it won't change your total cost that much, just a few dollars. Okay, so that's just to show us that if there is a change in our quantity of order, if we don't want to follow the Q star and order a little less or more, is that going to change a lot in our total cost? The answer is no. The formula is a robust formula.
So basically, every time we get a new annual demand, we have to calculate the Q star.
Absolutely, yes. So if the demand changes, you need to change your calculation and have a new Q star.
Makes sense. Okay, thank you.
You know, the Q star became Q in the total cost, I noticed. It became the order quantity.
Yeah, I mean, the total cost formula, right, is setup cost plus holding cost. But what do you want to replace for Q? To minimize your cost. That's the Q star.
It's per order,
Mm-hmm. I think you're
which would be the optimal order quantity, I guess.
Exactly. Because the main reason we perform all these calculations is just to minimize our costs, right? So we don't want to put Q other things. We want to put the Q star. We do all this calculation to find order amount, number of order units that minimizes the cost. So we use Q star. So you can see that only 2% less than the total cost of 125 when the order quantity was 200. So the next step, what is reorder points? So reorder point, so you know that the first time you put your order in this problem, at the beginning of the year, let's say in this problem, at the beginning of the year, you want to put order. How many orders do you put in? 200. You're not going to put 1,000 units, right? You're going to put 200 units 5 times in 1 year to reduce your inventory cost, right? So now, let's go down here. When your inventory is full, you will start selling or using your products. And there will be a time that you will know that in few days, you're going out of inventory. At that point, you don't want to have a few days without any inventory. So before the inventory ends, you want to put your new order, or you want to do a reorder. That time is reorder point. So it's very important to be able to calculate which day to put order, where when the new order comes in, we are already have finished all of our previous orders, and we have place for new orders coming in. Okay, so to calculate that, we are going to calculate reorder point, ROP. So the reorder point tells when to order. The time between you put order, the new reorder, until the items arrive at your inventory, that's called lead time. So lead time is the time before your inventory is empty. So lead time is the time between placing and receiving an order. So how do we calculate ROP? We multiply demand per day multiplied by the lead time. Lead time will be given to you. Lead time will be given to you. L is given. D is also given. How do you know? You have the demand for the year. You divide it by number of working days in a year. That will give you demand per day. You want demand per day? Divide annual demand by the total working day of 1 year. So in this example, it was 250 days, right? We divided by 250. So here's the thing. So when you initially put your order at the beginning of your inventory, your stock is full. That's your timeline. Your stock is full at the beginning. And we said that demand is constant, right? That means with a constant linear function, your items in the inventory is reducing until it gets down to 0. So there will be a time that you know when to put your order so that when your inventory hits 0, your new order has arrived and you can fill your inventory. How to calculate that? D times L. D times L. D, the slope of reduction, times how many days it takes for the order to come in. Okay? So let's see an example. Let's say the demand, annual demand is 8,000 iPhones per year. And let's say we have 250 working days in 1 year. So small d is demand for a year divided by total number of working days in 1 year, 250. That's 32 units per day, right? So what's the lead time? Lead time for orders is 3 working days. May take 4 days for some reasons, delay in the transportation, right? So we can calculate both 3 and 4 and take the best. So how do we calculate the ROP? D times L. D, we just calculated it, 32 units per day, multiplied by lead time. Lead time, how many days it takes for the order to come in? Let's say 3 days. 3 days times 32 is 96 units. If you want to go for 4 days, 32 times 4 is 128 units. Now, give it the time to yourself. If you are the manager, you have already ordered 200 units, you have 200 units in your inventory. After some days, you need to reorder, right? Can you tell me how do you use these two numbers? These are ROPs. How do you use these two numbers of ROP? Let's just focus on one. How do you use these numbers to place your order?
When the number of units in inventory drops to, for example, 128, we need to order
Exactly.
the optimal
Perfect.
number of units.
Yes. So today you have 200 units. You start selling your items or using your items. After some time, you're going to have 128 units. From this number, you will know that, okay, today I need to put order. And I know in 3 or 4 days, I'm going to have 200 units arriving at my inventory, and I will never be out of stock. Does that make sense, everyone? Think about it. At the beginning, when you start your work, you already have 200 units. After some times, you're going to use or sell them, right? So when to put the next order, or when is your ROP, so that you never go out of stock? That's your ROP point. So when you have 96 units left in your inventory, you need to put your next order, right? So the next is production order quantity model. So we're done with the basic EOQ model, okay? We're going to a new formula, and that's production order quantity model. What is the production order quantity model? It's a model used when inventory builds up over a period of time after an order is placed. What we mean is we are at the same time producing and using it, right? So it's not like the previous problem where when the orders arrive, suddenly our inventory arrives to the highest point. It's actually by time we will increase our inventory, and by time we will use it. By time we will increase, by time we will use it, right? So it's used when units are produced and sold simultaneously. We can say sold or used because some factories, imagine a factory makes make a part of a car by itself. So it produces the part and it uses and assembles into a car that is going to be sold, right? So they produce, they use it, they produce, they use it, or they produce and they sell it, produce and sell it. So it's going to be a little bit more complex now. So the more we move forward, we're going to consider more complex situations, and the more variations come in. So we're going to have different formulas. And by reading the questions carefully, you will know which formula to use. So for the production order quantity model, two variables are added. Small p, daily production rate. Daily production rate. How many items or units are you producing every day? And small b, daily demand or usage rate. Daily demand or usage rate. These values are given to you. These values are somehow given to you. We're also going to have Q, number of units per order again. We're going to have the holding cost, annual holding cost, and we're going to have the T, time, length of the production run in days. So one more time, really quick. If the production rate is given and at the same time you are using your production, your inventory will be production in a certain time multiplied by demand or usage times that amount of time. And then we replace time with Q over P. And where did that come from? Total produce is production rate times time. So we isolate T, and T is Q over P. And we substitute that Q over P in this formula for T. So we substitute T Q over P here, and we simplify it. Q is isolated or factored, multiplied by 1 minus D over P, right? So the P and P here is canceled out. That's a 1. And then we have a Q over, and then we have a D over P right there. So in the actual formula of Q star, this is going to be, again, the same as the Q star we had before, 2ds over h. Instead of the holding cost alone, we have holding cost times 1 minus d over p. And that's the only difference between this and the previous formula. And then we had an example where we have a production rate of 8 units per day and demand or usage of 4 units per day. We substitute all the numbers again, 1,000 unit multiplied by 2 times $10 setup cost, divide by $0.50 for holding cost, multiplied by 1 minus 4 over 8. So 4 is your demand or usage per day, and 8 is your P or production per day. And you multiply that, and on the square root, your Q star for production rate is 282.8. And we always round up to the next round number. Even if this is 282.1, you would round up to 283 to make sure you're not out of stock. We also said that if the annual demand rate and production rate is given instead of daily, in the formula here we have per day. If annual information is given, we're gonna simply use the annual information as demand rate and production. The next topic that we'll talk about is the discount model. So how discount works? Discount, when you order more productions, sometimes the supplier or the producer is going to give you discount because you're buying more items. So when you go to order, they normally give you a chart where it says initial price. If you buy between 0 to 119, the price per item is $100. If you buy more, especially if you buy between 200 to $14.99, they will tell you that the price is $98. If you buy 1,500 up to and more than that, they're going to give you the price of $96. Now the question is, which of these is going to give you the optimum or the minimum cost? So for each one, we can actually calculate the total cost and come up with a solution. So the total cost formula, if you remember, was the setup cost plus holding cost plus the production cost, right? That would be DS over Q, Q half times IP. So this used to be the holding cost, right? It was your holding cost. Now this holding cost is going to be replaced by I, which is holding cost per unit per year, expressed as a percent of the price, because we have a discount now, right? And multiplied by the price per unit. So Q is still the same, D is the same, S is the same. So the only thing here is changing. And the total product cost is actually price times the demand. So in the Q star formula that initially we started with, instead of H in the denominator, you have I times P. So let's see an example here. Let's say we have 52,000 units per year as demand. with a setup cost of $200. Let's say I is 28%. And the price given to us are $100, $98, and $96 as mentioned in the previous table right here. What are the steps we're going to move forward with the quantity discount model? Starting with the lowest possible purchase price. So we start with the $96, right? We're going to calculate the Q star until the first feasible EOQ is found. And what do we mean by feasible? Let's go back here to this chart. Let's say we start with $96. So what is Q star? Q star is number of orders every time we put order, right? Number of units we put in order every time we put order. So if with this $96 option, my Q star comes up as, let's say, 1,000 units. Is 1,000 units a possible or a feasible solution for this? Because this price is only available to me if I order more than 1,500. Does it make sense? So if I go with the $96 and the Q star I calculate is less than 1,500, then I can't take this option because that's not my minimum cost. Then what should I do? I go to the next level, next lowest price. I keep checking all these prices from low to high until I find a Q star that actually matches that category, right? So let's see. So this is a possible best order quantity along with all price break quantities for all lower prices. So one more time, starting with the lowest possible purchase price, calculate Q star until the first feasible EOQ is found. Calculate the total annual cost for each possible order quantity determined in step 1, and then select the quantity that gives the lowest cost. So we also calculate the total annual cost for each possible order quantity determined in step 1, and then we select the quantity that gives us the lowest cost. All right, so these are the total cost for no discount, discount 1, and discount 2. But each of them, they can be feasible or not feasible, right? So you can see that for $96, maybe it's not feasible because the lowest point is actually less than 1,500. You have to order 1,500 so that you can order $96. But your lowest point actually did not occur after 1,500. It's below 1,500 orders, so it can't be feasible. So let's see. Now we plug in the numbers for $96 first. So demand is 5,200 units. Setup cost is 200, 5,200 times 2, divide by I is given to us, 28%, and price is $96. You calculate this, that's 278. Is that a feasible solution? The answer is no, because to have this price of $96, you need to buy more than 1,500 units or more. So we have to move on to the next lowest price. The next lowest price we have here is $98. So we calculate the Q star for $98. All you have to do is to replace 96 with the 98. and that gives you 275 drums per order. Looking back at that chart, is that a feasible solution? So 98 is if you buy between 200 to 14.99. Right? So does that work for us? Yes, because more than 200 is acceptable. And our Q star is 275. So as a result, this can be a feasible solution. Feasible means it's possible, something that we can do based on the restrictions. Now let's look at the quantity discount formula. TC, total cost, is calculated for both 98 and 96. Although 96 was infeasible, we want to know what's the total cost if we use $96, right? For management, if there is not much difference between ordering 275 and ordering 1500, if there's not much difference in the number of total cost of the number of orders, we might decide to go for 1500. So let's see. So what I want from you is to use this formula to calculate these two numbers. Let's see how close you can get. So you have demand, you have the Q star for each one, which is right there. For this one is right there. For this one is the minimum, right? Minimum is 1500. Dollar amount are given. I is given. S is given. All of these values are given. You just need to substitute and find these two numbers.